Well, hello, everybody. Welcome to our webinar today on grid interactive buildings, enabling a resilient, clean energy future. My name is Joe Wachunas with Electrify Now. I'm here with my teammate, Brian Stewart, and we'll introduce our panelists, Isaac and Karina, in just a second. Welcome to the third day of Sustainable Building Week. For those of you who are new to Sustainable Building Week, this is a yearly event that focuses on how to make buildings more sustainable. So thank you to all the sponsors of Sustainable Building Week, including PAE and PGE, who are represented here today on the webinar. There's over 20 events at Sustainable Building Week, some online, some in person. Check it out. We will put a link in the chat to Sustainable Building Week. So great to be collaborating together. We are Electrify Now. And we promote beneficial electrification and try to boil down electrification into 4 steps to decarbonize your life. Number 1, clean up your electricity supply through rooftop solar panels, through your utilities clean energy program, or through community solar. Number 2, decarbonize your home. We'll be talking about decarbonizing buildings today, but we've had lots of webinars. You can find it on our YouTube channel, Google Electrify Now YouTube, on how to do that. Electrify your transportation is step number 3. A very important way to take a huge amount of your carbon emissions out. And number 4 is electrify everyone. Of course, those of you who signed up for today's webinar saw that we do ask for donations for Electrify Everyone. We are an all-volunteer organization, and so we like to collect donations, and we have partnered with a local nonprofit called the Community Energy Project to switch out old polluting gas water heaters with new efficient heat pump water heaters for income qualified households. We're up over 50 water heaters in the last year. Just through our webinars, we've raised over $4,000, and through other donations have raised much more than that. So we'll put a link in the chat. Thank you to all of our donors who donate time and time again through our webinars. Thank you so much. So this is day 3 of Sustainable Building Week and what we're calling Electrify Week. We're focused, of course, on many different facets of electrification. Our first 2 webinars, our first one was on all electric versus gas in new construction. That's on our YouTube page. Yesterday, we talked about heat pump water heaters. That's on our YouTube page as well. We'll put a link in the chat. Today, we'll be talking about grid interactive buildings, which Brian will introduce shortly. Tomorrow, don't miss our induction cooking webinar. We'll have our chef, Rochelle, who joined us last year, talking about all the different types of induction stoves that you can get and give you some tips on how to cook on induction. And then Friday, we will be talking about the intersection of equity and electrification with our Healthy Homes webinar. So we hope to see you at all those, and we'll put a link in the chat to the future webinars. Also, a real quick plug to our Electrify Coalition. We're 40 organizations strong and growing. We want your organization to join. There's no cost, just a belief in electrification. So email Brian or I to join the coalition. And Brian, what are we talking about today, and why is it important?
Thanks, Joe. So the topic is grid interactive buildings, and I like to start really pretty big picture when we give people a little context before we turn it over to our panelists. But why is it important to be talking about this? Well, I think the first place to start in this conversation is just a realization about how much new renewable energy we're going to need in order to meet all of our goals for carbon reduction, keep this planet a place that we all want to live on, because we only have this one. So we have a lot of renewable energy, new renewable energy that's going to be needed. So to give you an idea about that, today, well, this was as 2019, in the United States, we used 4.1 petawatt hours of electricity. That's trillions of watt hours. And you can see that the majority of that comes from fossil fuels based generation, although there's quite a bit that's non-greenhouse gas emitting. If you add up all the hydro, the renewables, the nuclear would be in that zone as well. So the first thing we have to do, obviously, is just clean up the existing generation that we have, replace that with clean renewables, and that's a big job. But on top of that, we're going to need more renewable energy as we electrify the transportation sector. And then on top of that, as we electrify buildings, which are the 2 really big moves that have to be made once we've electrified our electric grid, or sorry, cleaned up our electric grid. Electrifying buildings and transportation is going to add almost another 2 petawatt hours, roughly 50% more generation than what we currently have. That's daunting, but it's doable. I mean, you know, and it's happening. I mean, this is already going underway, and Isaac from PGE will be able to talk to you a little bit more about what PGE is doing in this area, but it's happening, but it's a big job. So that's the starting point. On top of that, the way we use electricity, and we're going to get into much more detail on this, but I just want to kind of introduce the concept of this idea that electric loads are not constant and consistent. They change throughout the day, depending on how people are using electricity in their homes and in buildings and in industry. It changes throughout the year. We have different demands at different months of the season. And here in the Northwest, you can see we're starting to develop this big spike in the afternoon hours in the warmer months, and that's just going to continue. All of us who experienced this last summer know that air conditioning in the Northwest is here to stay, and so that spike in the afternoon hours in the summer months is going to get bigger. So that adds another degree of complexity. We have a lot of electricity that we need, or new renewables we need. It's an inconsistent demand, and obviously, as all of us are familiar with wind and solar, you have inconsistencies in supply. So balancing all of that is a big job. And that's why we really have to give our utility partners a lot of credit for figuring this out, because it's not straightforward. But what we're going to be talking about today is how can buildings be part of that solution? How can smart buildings, with all the technology that's available today, how can we build our buildings to make that job simpler? And make electricity more reliable, and et cetera. So we're going to be diving into this today. Here's a few questions we're going to be digging into. You know, as buildings electrify, how is that going to affect electricity demand? What are the technologies that enable buildings to use less energy in the first place? Is it possible for building design to help us reduce some of those peak loads that we were just talking about? And can building design potentially even reduce the total amount of new renewables that we need? And then what is this going to look like when our buildings and our vehicles potentially even are also interacting with the smart grid of the future? So this is why this is a really important and interesting topic. And I'm really excited to have two fantastic panelists today to help us get into this. We're going to lead off with Karina Hershberg from PAE. She leads the development of microgrid designs, emissions analysis, and campus scale solutions for PAE. She helps projects implement regenerative solutions, resilient solutions through data-driven analytics and innovative electrical design. She was a key contributor on many really outstanding sustainability-focused projects, such as the Rocky Mountain Institute Innovation Center, the Georgia Tech Candida Living Building, the Beaverton Public Safety Center right here, and the PAE Portland Living Building. Great examples of exactly some of the things that we're going to be talking about today. And then we have Isaac Barrow from PGE. He's the commercial real estate marketing manager there, and he manages the expansion of some of these new products to key customers, including the integration and evolution of smart cities initiatives, which is exactly what we're talking about. He also oversees recruitment of large commercial customers and economic development in partnership with regional agencies and jurisdictions. So Isaac knows a lot about what this looks like in practice. Karina and her firm have been doing a lot of the design work to make this work at the building design level. So we have two really excellent presenters here. I'm super excited. And with that, I'm going to turn it over to Karina to get us started. While we're transitioning here, I would just remind people, use the chat however you like. If you want to let us know where you're from, we always like to see that. But if you have specific questions, please put them in the Q&A, and we're going to do our best to answer them along the way. And if we don't get it to you along the way, we will have a good Q&A section here at the end.
All right, is everything looking okay on the screen there?
Looks great.
Excellent. All right. Well, hello, everyone. Thanks for joining us today. That was a great intro, Brian. I think you hit on sort of the key questions that we're out to answer here today. So just quick introduction on PAE, and then Isaac will introduce PGE in a little bit more detail later. So PAE, we are an engineering design firm. We're located here. I am in our Portland, Oregon office, but we've got offices, Seattle, San Francisco, Eugene as well. And we say that our vision is to help solve the planet's energy and water challenges. So we do mechanical, electrical, plumbing technology, and lighting design. And then we also have a wonderful modeling and analysis team. And I kind of bridge the two worlds between electrical and modeling and analysis, which is handy because today's topic is blending of those two worlds as well. And so we use all of those to help hopefully solve the planet's energy and water challenges. All right, so we're going to dive into our topic today. And this is something Isaac and I are really excited about presenting. We're both just really fascinated by this topic. We talk about it a lot. And I would say that we talk often as much about some of the kind of a philosophical thought around it as much as we do the technical. And so we thought it might be fun to share a little bit of both of those worlds here today. And kind of one of the reasons for it is I think sometimes, you know, when we're solving technical challenges, it is helpful to sort of zoom back out, pull ourselves out of the details for a little bit and think about the context, the larger context in which they're rooted, because it oftentimes kind of helps us lead us towards solutions. And so part of in this one, having a little fun with the philosophy of it and going a little bigger picture can actually kind of help us understand a little bit more of what does this actually look like in practice. So we're going to go through the philosophy, then we'll get into some technical theory, and then rest assured, we'll end with the analysis and the kind of application pieces of it, and there will be bar graphs. I'll just go ahead and say that. We'll give you the data too. So, all right. So with that, let's think a little bit about energy, right? And our relationship with energy. And if we pull back from buildings and just think of it in the context of at a planetary scale, right? A healthy, mature ecosystem, what does that look like? It's a series of, you know, cycles and flows and systems that are in balance, right? And so from an energy perspective, the energy that's available is what's used, and the systems that are there are optimized in a way that they work within that availability, right? The resource, they know what the resource is and they know how to optimize it and kind of live within those bounds. And so if we kind of pull that in, what might that look like, right? Is that we have, you know, within those energy flows that happen, right? There's a cyclical nature to them in many ways, right? So we have summer and winter, right? In summer, we have more sunshine, more daylight, more heat, right? In winter, less sunshine, less daylight, less heat. Similar sort of thing with that nighttime, you know, daytime switch. One has lots of, you know, a lot more access to heat and light. The other one has less. And then if we think about the sources of them, right, from a renewable perspective, sun and wind are the ones that we see most. And so if we kind of think these concepts, right? So again, that big picture, and then pull that into the building, we start to see some of, you know, why it is we are where we are today in kind of our relationship with energy in the built environment. And so if we kind of walk through, you know, the history of buildings and our relationship with buildings, if we think to sort of original structures, right, which for much of human history was what we had, and in many parts of the world is still the most common form of built environments, right? So it sort of has the fundamental functions behind it, right? It provides shelter from the elements, it provides a gathering space, but it doesn't necessarily have lots of energy inputs into it, right? It really is more of those kind of fundamental functions to it. Then, you know, buildings sort of changed a bit, right? There were different approaches started to bring energy into that environment. You know, initially it was often in forms of, you know, biomass and having, you know, fires for cooking and for heat, for light. And then from there, we kind of moved into forms of fossil fuels, right? And so that kind of brings us into what we call sort of the modern built environment. And one of the big changes that happened, particularly going from kind of stage, you know, or option kind of 2 to 3 here, is that we also developed this concept of, conditioned environments. And we went from having sort of a direct relationship with some of those cycles that we talked about, right? In the winter, you wore sweaters, and in the summer, you wore lighter weight clothes, to this concept that you can have, light in your structure 24/7 and a temperature range of 68 degrees Fahrenheit to 72 Fahrenheit year round. Right. And so there was this fundamental shift that happened where we really became very sort of disconnected from those kind of more, what exists in sort of the natural world. And there are reasons behind it, right? It's comfort is one of them, right? Safety, health. There's a lot of reasons why the built environment went that direction. And there's a lot of advantages to it. But it also has resulted in a lot of problems, right? A lot of the fossil fuel issues, and then obviously the climate crisis we find ourselves in is directly tied to some of, the building industry is, as a sector, is one of the greatest contributors to that problem. And so the question that we find ourselves at now is, how do we move forward into this climate positive buildings, right? Is there a way for us not to necessarily return to any of these previous states, but can we pull the best parts out of each of them, leave, maybe shed the worst parts, right? Pull those best parts together and move forward with this idea of climate positive buildings. And so obviously kind of the idea behind it, right, is that can we move the built environment to be in a place where it acts more like what we would consider to be a balanced, mature, healthy ecosystem. All right. So that's the philosophy. See, that's fun, right? I like that part. Okay. Now let's get into some of the technical theory. So, the issue behind all this, right, is that why we talk about grid interactive buildings and how do we, bring them into a place of balance, is we're just really fundamentally coming down to is the interrelationship between energy and greenhouse gas emissions, right? And how do we get that to a point where we can get the benefits from energy without the negatives of the greenhouse gas emissions? Obviously, the big topic around this is around grid decarbonization, and can we, get to a point where we have zero carbon or zero emissions electricity? And that is certainly the direction that it's heading. These are the utilities, some of the major utilities along the West Coast. And Isaac, I apologize, I still have the old PGE one. PGE's is even better than what's shown here. But all of them are heading in that direction, right? The long-term goal and the trajectory that they're on is towards that zero carbon grid. The problem, and where grid interactivity comes in, is that this is an annual outlook, right? This is each year we're moving towards grid decarbonization, but that's not actually how the grids work, right? They don't work on these discrete annual chunks. It is a very, very dynamic system. And so within each of these hours, there's 8,700, and there's each of these years, there's 8,760 hours within it. And within each of those hours, there is something very unique happening at the grid at any point in time. And that's the piece that we're trying to tap into and help with grid interactive buildings. And what this really comes down to, this is an example of kind of the Northern California's grid. And this is a heat map of the hourly emissions of that grid. And what you'll notice is that it's not just one kind of monolith color, right? There is variation. And what that is telling us is that there's variation in the emissions every hour in that grid. And so as a building, what that means is that the energy you're using at any point in time might have a different emissions impact depending on when you're using it. And that's kind of an interesting thing to think about, right? Because you think, oh, if I turn my light on today, it's the same impact as if I turn my light on tomorrow. And that might not actually be the case, because it depends on what's happening on the grid at the time that you turn your light on. And so the challenge we find is that some of the kind of more annual outlook solutions that we have around decarbonization are missing this really fundamental concept of the importance of considering time within our emissions impact. And so this is where grid interactivity comes to, is how can we get the energy use of buildings to better align with the sort of emissions reality of the grid, so that way we're reducing energy use at the grid's highest emissions times, and thereby getting the best benefit and also helping the grids better balance their own resorces.
Karina, can you just explain what the difference in color in that last chart?
Oh, yeah. So on that one, sorry, it looks like I'm stuck here. There we go. So the example here, the grid in the green area is when the grid has the lowest emissions. So in the spring, in California, right, it's really mild temperatures. Nobody's got their heat on. Nobody has their air conditioning on yet. And there's lots of solar. So it's a really clean grid. And so your energy use at that time could potentially already be zero emissions. Some days it can be close to zero emissions. We move into the summer evenings, right? So everybody, they come home from work, it's really hot out, they turn on their air conditioning, they start making dinner, they do a load of laundry. The grid all of a sudden, and PV, right, sun starts to set, so PV is starting to come offline. The grid is in a tougher spot, lots of load, not necessarily as much PV. And so that's when we start to see some of the higher emissions resources come on, like the natural gas peaker plants. This is just another fun kind of visualization on it. This is the grid at kind of a national level and the emissions profile throughout the year. And as you can see, it's this super kind of dynamic, you know, changes throughout time. It's not the static single number. It's at any point in time, it is in a different state. And so what grid interactive buildings are trying to do is, again, to try and help buildings become just as dynamic as the grid actually is. And to make it even more complicated, the grid isn't just this giant kind of national, you know, single entity. It is different region by region, right? So different regions have different emissions profiles and different needs depending on where you're located. And so what a grid interactive building, it's not necessarily this kind of one size fits all solution. It's more about matching your location with the specifics of your grid region. So, you know, again, as a homeowner, right, I participate in a demand response program, which is a form of grid interactivity. You know, here I get messages, you know, about doing load reductions in the summer and in the winter because I'm in a, you know, I'm in a climate here in Portland where we have peaks in the summer and we have peaks in the winter, right? And that might be different than somebody in Southern California who only has peaks in the summer, right? And so some of the grid interactivity, again, is that we start thinking about, and that's sort of that ecosystem analogy, is think about the reality of your location, right? Because the specifics of your location might be different from the ones of another location. So that brings us to the grid interactive flexibility. And there, I would say there's so many terms that float around this, and I'm using them fairly interchangeably. So we have grid interactive buildings, demand response, load flexibility. Really what they're all saying is that all of those are just saying having grids and buildings talk to each other and work in a way that's interactive. And that's really what is needed to get us to that decarbonized state, right? When we look at grid decarbonization, a lot of the conversations are around the sources, right? Wind and solar and moving to renewable sources. We also look a lot at how much, so quantity and efficiency, right? So energy efficiency. And so what this does is add in sort of that third really, you know, critical component of time, right? We want efficient buildings with renewable energy that are balanced in terms of time. And that's really what's going to get us to that, you know, grid decarbonization and that decarbonized energy and buildings sector state. So with that, I'll hand it over to Isaac.
Hey everyone, really glad you're here with us. And I had to chuckle when Karina said at the intro that don't worry, she'll have bar charts, because I know Karina well enough to know that not only does she have bar charts, she has three-dimensional rotating graphs that pinpoint hourly emissions over an 8760 period. I mean, this is, and I really appreciate a partner like PAE that actually holds our feet to the fire and holds us accountable for our statements and asks really tough questions about, well, can you prove that? So I'd like to start first with a little intro on what or who PGE is, Portland General Electric. I noticed in the chat, somebody reached out from PG and E, our partners to the South Pacific Gas and Electric. We are Portland General Electric, though I did take his email and I will follow up because we're always looking for good talent. Portland General Electric, we're one of 3 investor-owned utilities in Oregon. We cover about 50% of the state's population, mostly centered around Portland and Salem, the large industrial centers, but about 80% of the state's electrical load. We are our own balancing authority, so we own our own generation, manage our own transmission and distribution system, and it composes about 3,300 megawatts of generation. The mix currently is about 10% wind, 20% hydro, 40% conventional, and conventional is thermal resources, so gas plants and combined cycle turbines. No coal. We retired our last coal plant last year, about 5 years ahead of schedule. And critical to the emissions discussion, we have about 30% purchase power. We participate in the energy imbalance market, so we're actively buying and selling energy up and down the West Coast, everything from year-ahead contracts to 15-minute incremental contracts. So it gives us a lot of flexibility in managing resources and pricing for our customers, but also makes it a little tricky because our mix is not static at any point in the year. I also want to touch on the next slide that we're also, utilities aren't created equal. And I think it's important to start off with saying that at PGE, we see ourselves as our customers' clean energy partner. We all have to work together to address the pressing necessity that climate change presents. And so we are very much trying to encourage our individual customers, industrial, commercial, residential, to be on their own path, whether this is subscribing to one of our renewable power programs, whether it's installing solar or other on-site generation resources. We love to be part of customers' battery and microgrid projects, a lot of the work we do at PAE. So this is, unfortunately in the US, not all utilities are created equal, but we are very happy to be championing the way towards our clean energy future. So what is a modern grid? In the past, there was 2 factors that really determined what our role was. We needed to make sure that the power provided was reliable and affordable. And these are still very key factors, but what we're seeing is a growth of what is determined as important to our customers. And this now includes the need to be resilient, flexible, and of paramount importance, clean. So what does this mean in actual practice? This means that the grid moves from a one-way flow of energy to a two-way flow. That management of the two-way flow needs to be as automated as possible and as flexible as possible. And these combine to really mean that there's an increased reliance on communication and data around customer participation. Said differently, flex load, flexible load, demand response becomes very important in the grid of the future. So what does our flexible load portfolio look like? Thankfully, we have a number of active programs as well as programs under development. And all of these combine to give customers, ideally give customers at every level, options to lower the emissions of their end use by incorporating that flexibility. So I'm just going to touch on a couple. And on a commercial industrial side, we have our Energy Partner Program. Energy Partner Program is a program where we will actually have an engineer walk through your building with you, look at what loads can be flexible. Do you have variable speed pumps that you have flexibility over? If you don't have variable speed pumps, are you a manufacturer that actually has flexibility in running 3 lines instead of 4 at various times of the day? And we'll come up with a customized load shed plan, ideally as automated as possible. And we'll actually pay our customers on a monthly basis, regardless of whether they participate in called events or not, simply based on their commitment to engage in that flexibility when asked. Another fantastic program is a multifamily water heater program. I know Electrify now did a session on heat pump water heaters yesterday. The multifamily water heater program goes to multifamily buildings where they have individual heat pump water heater units in place, installs a little communications module on the top of it that allows for automated flexibility. I think it was Terry that pointed out in the chat the ability of load shifting, and that's essentially what the multifamily water heater program does. If we're anticipating high emissions or high costs in the afternoon, say between a 3 and 5 peak load period, going back to those charts that Brian was showing at the beginning, we're able to send a signal out to all 12,000 plus water heaters that are currently in the program, preheat between 2 and 2:30, don't heat between 3 and 5. Customers don't notice it, and we're able to make a dramatic difference in the overall energy use and the emissions associated with the grid. Of the 12,000 plus water heaters we have enrolled, and this enrollment is actually done through the property managers of the buildings, we've had 2 people complain. And that's after 2.5 years of scheduled program operation. So very high satisfaction. On the residential side, we have a smart thermostat program. This works with like a Nest learning thermostat, where a residential customer can say, this is my comfort range, that 68 to 72 window that Karina was talking about. And we look for flexibility within the user's set comfort range. So if it's at 68 and they say they're comfortable between 68 and 72, we'll ask the thermostat to bump the temperature up to 70 degrees. And at any time, the user has an override function. They get a little orange light that lights up around their Nest. And if they're not comfortable, they simply walk up to the thermostat, twist it, and override the system. And then we have a voluntary program, peak time rebates. It's our behavioral demand response program. This is the one that Karina was referencing a minute ago. We'll get into some more details, but it's essentially a call and respond type of action. So we send a text message out to the couple 100,000 folks that are in the program, asking them to shift loads. They'll voluntarily decide what loads they want to shift. They'll run the dishwasher, delay washing their clothes, and we'll give them a rebate based on their participation. Number of programs under development. I'm very excited about battery storage. I know there have been a lot of questions about vehicle to grid. The EVSE mentioned here is electric vehicle support equipment. So it's the first step in that direction. It's the smart charger, sending signals to the charger of when to charge and when not to charge. We're not yet at the point of pulling energy back out of vehicles, but I'm very excited for the Ford 150 Lightning, which I feel is going to really push this technology into the marketplace at a very fast rate. And then we're looking at commercial sized heat pump water heaters. I need to also mention our smart grid test bed. This is an area where the PUC has allowed us a little more flexibility in exploring the potential and value of demand response and distributed energy assets like batteries. Within these smart grid test beds, we have 3 in our service territory right now. We aggressively deploy distributed flexibility across all segments. For example, we're testing a residential connected water heater program now. I'll touch on our residential battery pilot in a second. But the key takeaway here is that through communication, we're able to achieve very high rates of voluntary participation. Almost 2/3 of all customers are enrolled in some form of DR program, which is great foreshadowing of where we'll likely end up within a couple of years across our entire territory. So how is our grid moving? We have this concept of traditional generation, of this one-way flow. We generate it, we transmit it, you use it. The direction we're going is to what we would call a virtual power plant and smart grid, where we're responding to inputs, and those inputs could be price, could be demand forecast. The piece that's missing here, and I apologize for not adding, it seems like a big omission now, is emissions. Like we're responding to these, not just price forecasts, but emissions forecasts. And the smart grid, us as the utility, then works to optimize what that flexible energy use is, how much energy storage we can pull on, what solar assets, what wind assets are available to maximize the amount of emissions or maximize the amount of renewables, reduce the amount of emissions. And our role as utility transitions from provider of electricity to optimizer of the system, managing both demand side and generation side to really provide everyone with the cleanest, most reliable, and most affordable power that is achievable. Kind of continuing this trend a little bit, there's different stages of demand response. There's this direct load control. That's the turning off of a manufacturing line when asked type of response. There's this basic DR that really gets to this two-way communication. So maybe it's your commercial building that has heat pump water heaters installed, and you're working through a intelligent energy management system in your building that sends this two-way communication back and forth. Where we're headed is this real-time control, where you have essentially every connected device has some level of intelligence to it. And you have it's called high touch from the customer, but really what you as an end consumer gets to do is set what your comfort range is. And behind the scenes, the utility works with those parameters, uses AI and machine learning to really maximize that optimizer role of the system. And this is all done in service of reduced emissions. So I thought it'd be nice now to take a look at an actual peak time rebates example. So this is the voluntary demand response program. This one's back from June 23rd, a 3-hour event in the afternoon. We sent out text messages to 90,000 customers on this specific day. And it's that voluntary message. There's a PTR event. Please reduce your usage if able. And there's usually some ideas that go along with that, like don't wash your car, don't wash your dishes, don't plug in your car. Of the 90,000, 52,000 participated to the point where they earned rebates. About $100,000 in rebates was distributed. What's interesting about the rebates is because we're offering the rebates based on our deferred cost of capital, and this is usually at a very high cost time of that duck curve that we're looking at. The rebate's generally a 10-to-1 factor. So if you're paying for residential electricity at about 10 cents per kilowatt hour, the rebate you earn is generally going to be about $1 per kilowatt hour. Individually, I think what's really cool about this program is individually the average reduction was 0.12 kilowatts, which does not seem like a lot. In aggregate, it was an 11 megawatt per event hour event, which is very significant. It's significant enough that it allowed, I don't know if this is a specific case on the day, but just in terms of size, that is enough of an impact that it would allow us to not turn on another combined cycle turbine at a thermal plant, which is typically what the option would be at that time of day. So very significant. Another program we're touching on is our smart battery pilot. And this is in our smart grid test bed, one of those areas I talked about a little bit earlier. We are working towards the deployment of 525 interconnected batteries. Batteries are fantastic because as individual customers more and more are looking for resiliency options or ways to maximize the benefit and use of their on-site solar. PAE is definitely a regional expert in this field of microgrid deployment at both of the commercial and other scales. The thing about batteries is they're fantastic for customers in that 1% of the time that they're disconnected from the grid. But if we work in partnership, we're able to find ways to use them in the 100% of the time, including the 99% of the time the building's attached to the grid. And so they end up being fantastic, flexible resources. And I'm really excited to see this program grow and the commercial variations of it to get out there. And then on the non-customer side, we're also, I should mention, we're actively deploying batteries everywhere on our grid. We have Wheat Ridge generation station, that's 300 megawatt generation that combines wind, solar, and about 30 megawatts of battery. We're working on substation batteries. We have batteries in a couple of our buildings that we're building, and we're actively working with a number of customers on their microgrid deployments as well. I think with that, I get to turn it back to Karina for this awesome case study.
All right, thanks, Isaac. Yes, and I will say, although Isaac is right, I do not let him and his team off easy. As somebody who works with a lot of electric utilities around the country, PGE really is one of the kind of thought leaders, I would say, with a lot of these programs and a lot of the work that they're doing and conversations they're having. So it's always good to partner. All right, so we're going to end with a bit of a case study here and our promised bar charts. So what we wanted to look at, this was actually an analysis we did. So I don't remember if I mentioned this, but I'm our regional leader for our analysis and modeling group. And so we wanted to do a case study that kind of tested out this theory, right? And understand with this load flexibility, how much potential is there at the building side to make an emissions reductions impact. And so for this particular example, we did look at, Isaac gave that residential example that was actually data from an actual event. For this hypothetical one, we looked at a commercial scale building. So it was a fairly typical downtown kind of urban, scaled building, efficient, but not kind of overly so, just sort of again, just what we would consider to be a high performance modern building. And we decided to model it. We didn't include anything like on-site solar. We really just wanted to look at the building loads itself, because that's, I think, one of the things that's so interesting to me about the load flexibility concept is that although it can include hardware like on-site solar or batteries, it doesn't necessarily have to, right? It can be behavioral, or it can be just more optimization or changes within the systems you already have. And so in many ways, it can make it a little bit more accessible to more locations, because you don't necessarily have to change anything about what you already have. You just use it a little bit differently. And so we wanted to kind of test that sort of specific example of, if you just use the building a little differently, how much benefit can you get out of it? And I'm not gonna dive too much into kind of the methodology we use. If there's questions on it, we can handle that in the Q&A. But where we landed is the results of it is that what we did is we overlaid PGE's hourly emissions profile and set the model up in a way that it went into this kind of demand response mode, this load flexing mode, again, just using the systems we had by looking at things like expanded temperature ranges and some reductions in building loads in other areas. And anytime the emissions on the PGE grid would go above a certain point, we would switch into this other operating mode. And what was really fascinating about it is that it did provide a fairly, a meaningful amount of emissions reduction. And even when we think in terms of the energy use, it was like a 2.5% reduction in total energy use, right? Which isn't tons, but isn't zero. And as we move towards efficient decarbonized buildings, like every little bit does count. But what was interesting about it is that resulted in a 4% reduction in emissions. And so what it essentially tells us is that you get more bang for your buck, which makes sense, right? Is that you can have a bigger emissions impact with the same energy use just by being more strategic about when it occurs. Now, the part that we can't quantify here is, what did this mean on the grid scale, right? If you start adding all of these together, right, you have multiple buildings doing the same thing, all of a sudden you're at a point where you're starting to take some of those higher emission generation sources off entirely, right? And that's a harder one to quantify, but that is really how grids are going to get to a decarbonized state. And so I think that's what's kind of interesting about this whole, the grid interactivity and the load flexibility programs, is that it is not necessarily the piece of grid decarbonization that gets the most attention, but it is one of the more important ones. And it's the one that more of us can participate in, right? I can't personally do utility scale solar installation, but I can change how I operate my house. And so in this case, like that commercial example, it doesn't take that many sites. It only takes, in this case, we're looking at maybe about, just under 60 of those buildings participating in this. And we're looking at least one, maybe even getting it to two of those higher emission engines coming offline entirely and not even need to be used, right? Which we start to, gosh, wow, that's individual change can in fact help enable system-wide changes. And again, I kind of mentioned this already, but it's like the thing I like about it is that you can do a hardware solution, but you don't have to do a hardware solution. And the more, if you put in things like batteries and PV, you can do more. So you can kind of go farther, faster, sort of a scenario, but you can work with what you have today and start to participate in these programs. So that way you're having immediate impact, right now with what you have, with not necessarily any additional first cost or investments. And that's true both at the commercial scale and the residential homeowners. Like I said, I participate in the demand response program for that one that Isaac shared there. And it was all manual in that particular example. My family did it all manual. So the benefits of this, right, is it gives us resiliency. It can be resiliency at the grid scale, also at the building scale. A lot of the same systems that we use for grid interactivity are the exact same systems that we use for resiliency, energy resiliency. Occupant satisfaction, again, Isaac mentioned generally fairly high satisfaction rates. Occupants either don't particularly care or they don't even know that it's going on. And then it can help with operating costs, right? Because not only are you reducing your energy use, so there's a direct cost to it if you're participating in one of those programs that Isaac mentioned, and those are available. Obviously, we were very specific to PGE here, but what he mentioned are available in other utilities in other regions as well. There's usually good incentives associated with them. So, homeowners, apartment residents, and the commercial building owners generally all have access to those incentive programs.
What I think here is, what's important as I look to the future here is that the future really is grid interactivity. And I should start this by saying that, a lot of the foundational work was done in 2019 as part of our integrated resource plan. This is where we filed publicly what our intentions are for the next, I think it's a 20-year plus horizon on how we're going to meet the anticipated demand. And along with the last publicly recognized IRP in 2019, we did a deep decarbonization study that looked at what the various pathways were all the way out to 2050 under 3 different scenarios: a high electrification, low electrification, and high distributed energy assets. What the graph shows is that especially if you look at the high DER, distributed energy resources pathway, which is very much the pathway we're on and we anticipate remaining on in order to meet our emissions goals, over half of that end use flexibility, our end use DER, is coming from flexible end uses. And that is exactly what we're talking about here, that grid interactivity. And so really that underlying message, the future is grid interactive buildings, can't be underscored enough. One thing I do want to point out is that we released the decarbonization study and made commitments in 2019 around reaching an 80% greenhouse gas reductions by 2050. Late last year in December, we made a voluntary commitment to accelerate those goals by 20 years. And so we set ourselves on a pathway to reach 80% greenhouse gas reductions from the 2010 baseline by 2030 and 100% emissions free for the power we serve our customers by 2040. And those are only 9 and 19 years away, respectively. And so we are updating our IRP. It should be released, I think, the first part of next year. But these numbers that you're seeing for 2035 and 2050, you can essentially accelerate those to 2028 and 2032, respectively, around that range in terms of where we need to get to in terms of flexible end use demand. So right now we are a dual peaking utility. So we have winter peaks and summer peaks that are very close to each other. Last year, we were looking at about 140 megawatts of winter demand response and a little over 200 of summer demand response. And we are essentially working to not quite double those, but get to about 250 megawatts of flexible end use demand by the end of next year. And we'll keep on that growth trajectory. And so we're working very hard to continue to introduce customer-centric programs that help us reach these goals.
All right, so looking forward, right? Climate positive buildings. How do we get there? We can do it. We can have all the good. All right, so what are kind of our takeaways? First is decarbonization of the energy sector requires dynamic strategies to meet dynamic needs, right? The building side of the meter can't assume that the utility side of the meter can do it all by themselves. It has to be a partnership. And that does come from, having grid interactive buildings. And so, takeaway number 2 is that those are really important elements towards energy and building decarbonization. It has to be a partnered effort to get us across that, super critical finish line. And so, what we can do as either, folks who, we're all occupants of some building somewhere, implement building systems that are flexible and grid interactive, right? And you can do it at a residential level, you can do it at the commercial level, you can do it at both. But making sure that we are moving buildings over there as we're electrifying them, making sure that those electrification solutions are also can achieve these flexible and grid interactive features. If for anybody, when you're thinking of your own home, and again, this is whether you're a homeowner or in a rental situation, if available, sign up and participate in your local utility demand response program. As you saw, a bunch of individuals adds up to a really big impact. And it's one of the ways that we can, as individuals, influence the most kind of systematic level impact, system-wide level impact. And then just in general, continue, working towards climate positive designs, right? It includes things like passive solutions and energy efficiency, but then also the grid interactivity that we talked about here today, and then the renewables, on-site renewables, or some sort of community solar program if you have it available, or green energy program that Brian and Joe had mentioned earlier. All right, I think that's what we got.
That's fantastic. Well, thank you both. I wanted to lead off with just a question. We've got lots of questions in the chat, so plenty to talk about here. But I love that. I was thinking about your kind of case study, and it's so impressive when you can see that how just a relatively small participation can lead to things like taking gas peaker plants offline. That's very tangible. Can you just describe a little bit, like, okay, imagine that you were working in one of those buildings, let's say it's an office building, and you're working in the building, and then you have one of these events, or or the building goes into this kind of flexible demand mode, I think is what you called it. But what would you experience if you were living or working in that building during that event? What would it feel like? Would you even notice it? What would you notice?
So it kind of depends on how the building does it. And that's where it's, different solutions have different impacts. So we do see a lot of kind of at the commercial scale, we'll see customers, our building owners are putting batteries in, because that way the battery kind of handles the load flexibility piece, and it is truly invisible to the occupants. They have no idea that anything has even happened, because all it is a battery discharging. A lot more though, and this is the more common one, I would say, and I'd say demand response programs too, I'd say have been in place longer in California than much of the Northwest. So a lot of building owners and people and folks down there have been, kind of experiencing this for longer. And I would say that, some of the clients that we work with down there, they have just communications plans in place. And it depends again on what level they're participating at and kind of what program they're in. But if they are going to do something like maybe expand temperature ranges or reduce some of the interior lighting, although at this point, you shouldn't have too many lights on near windows during the day anyway, with kind of the, control systems that we have. But what they'll do is they'll send a message out the day before that just mentions, hey, between 3 and 5 p.m. tomorrow, we'll be expanding our temperature range a little bit. Make sure you dress appropriately. And what we've heard from them is that communication piece is super critical. And as long as people know that it's coming, they know why it's happening, they're prepared for it, they're kind of, it's okay, we're doing this today. And they know that doesn't happen that often. It's only maybe 10 times a year. So single days, right? That they have very, very few complaints or very much pushback on it. And that people just kind of adjust, and it's been okay. I'd say at the, kind of residential scale, or even with other systems, Isaac mentioned preheating with hot water heaters. That's one that again could be almost invisible, because it's a hot water heater is thermal storage, right? It's just another form of a battery. It's just using your water as a battery. it can be almost invisible to occupants to not even know that it happened. So.
Well, a follow-up on that, Karina, a couple of people are asking, this is a kind of a case study from Oregon, from PGE territory, which might be a little more liberal leaning. What about other parts of the U.S.? Do you think, have we seen, that residents especially would be willing to let the utility have some control? How do we respond to folks who are maybe nervous about that?
I'm happy to give my perspective there, Karina. I mean, first off, what I would say is that we should approach this by respecting customers' concern. Like, I mean, we can show them the data, but if they're not comfortable with an automated signal to their devices, that's their prerogative. And so I think the challenge is, how do you design programs that help customers meet us from where they're at? And everyone gets to be part of this journey that we're collectively on towards a clean energy future. And so the cleanest example that comes to mind is we have this smart thermostat program that will automatically send signals to thermostats and adjust your heating and cooling within range. But we also have a peak time rebates program that just sends you a text message saying, hey, you're in that window. And that gives you the option to get up and control the thermostat. And so I think it's more a challenge of not trying to necessarily force anyone to agree to some level of connectedness, but to create ways for everybody to participate.
I wanted to dive into the battery thing for a minute because, I get this, well, this is a personal experience because we are looked into putting in batteries here in our home, and we did a webinar on resilience just recently. We had a lot of questions about this, and I find myself having, while I'll be adamant about some things like heat pump, space heating and heat pump water heaters and clean electricity coming in your home and electric vehicles, I find I have to be really a little bit equivocal when it comes to home backup batteries because they're so expensive and you use them so infrequently that it's a little bit hard to justify, I think, for a lot of people, including myself. I kind of feel like I'm not sure I'm willing to spend that money. But when you think about it in terms of what you guys were just talking about how imagine these distributed batteries, that they're small batteries all over the place, and that by tapping into them, you can potentially avoid building more generation or avoid these other really huge capital investments. It feels like there should be a way to spread the pain a little bit from the homeowners to take, if you were. So I know that that's part of what you're talking about with your battery program, but do you see a point where that could help make these home level resilient systems more kind of affordable and attractive to homeowners to put in the first place, or is that just asking too much?
I mean, it's a couple different thoughts on that. Yeah, I'd say prices right now does make it fairly hard in markets that have fairly low electricity rates and not too many peak time of use charges like the Northwest does. The grid interactive batteries really don't pay for themselves yet in our utility tariff structures. California, though, one of the reasons that market is so hot with them is that they can pay for themselves in under 5 years in many cases, sometimes even under 2 years. So some of it depends on the market. I definitely understand in the Northwest, the financial model of it does make it a bit of a struggle. And so I would say a lot of us in the industry, what we're kind of keeping our eyes on is just the price per kWh as it's coming down. Has come down faster than expected. And I think in some ways, faster than even PV did for a while there. So, we expect eventually it will probably get to a more accessible price point. Also, as, utility tariff structures or as the incentive programs change, I think we'll see that financial analysis come together. One thing I saw just kind of some of the chats flying through some questions on LCA for batteries, which is essentially the embodied emissions, the emissions associated with building the batteries in the first place? It's a really valid question. And I would say from a design perspective and an analysis perspective, because I do a lot of greenhouse gas emissions analysis work, is that when you do dual purpose, that's one of those great examples where if you use a single asset for two purposes, which is what some of the pilots we've done with PGE has done, is we took a battery, put it on a customer site, and set it up in a way that it was grid interactive when the grid was operational, so that it got benefit, right? It was provided grid support services. And then if the grid is to go down, it provides resiliency services to the customer, right? So it's this good example of a single asset, both from a financial standpoint and an embodied emission standpoint, providing two different really critical functions. Because I would say that the kind of emissions analysis of batteries just sitting there purely for resiliency purposes does bring a little bit moment of pause. But if you're using it for kind of the two reasons, right, you're getting rid of a diesel generator and you're supporting the grid with this emissions work, that's when the math kind of starts to look makes a little bit more sense.
So you were talking about the sorry, just to build one last thing on that, you were talking about these the rate structures in California, and just for people who aren't familiar with that, basically what it means is that at peak times, you could be spending twice per kilowatt hour what you are during non-peak times for your energy bills. And so it's a lot of money. And we don't have that here in the Northwest for the most part for residential customers, although some of the commercial customers might be seeing that. But Isaac, this is a question for you. Do you think that there's a chance that might change? I mean, you can kind of understand the philosophy of that concept. It sort of makes sense because it sort of, should encourage good behavior, right? To use electricity when it's available, because when it's cheaper because it's more available, and more, I think it's going to be cheaper because that's when your renewables are running. So it should, what do you think about that? Might we see a change there?
I think that a change is likely. And obviously we're regulated, so any changes have to go through a PUC and their approval process. But we've done some analysis that shows that we have customers that would actually benefit and like literally save money by a switch to a time of day use program. And so I wouldn't be surprised if that change was not too far out, where not that everybody would move to time of day, but that people will be given the option to enroll in a time of day program. And it's exactly what you said. You want to reward and incentivize people that are already doing the behavior without being rewarded or incentivized. To Karina's point on the batteries in the last question, I mean, I think the numbers, the preface is that Karina has often joked, and not just Karina, but others have also said that this work would be easier if we charged more for power. We're not going to, but it would make the numbers a little bit easier to get to.
I've never said that. It would make the math easier.
It would make the math easier. We're incredibly fortunate to live in a part of the world where our energy is already relatively clean and also relatively inexpensive. But the batteries are getting close. They're like for our residential pilot program, we're able to offset about $3,000 of the average installation. So for your average installation is about $8,000. It's not half. It's something. It's a contributing factor, and that number will likely change as the need and the rate structures around addressing emissions get better.
Yeah.
One thing I do want to call out, and I think it's worth a little bit of discussion, is just the role of large hot water heaters. Like, I mean, I think Karina did just say this, but hot water heaters are effectively a battery. They're a thermal storage device. And there's some really good companies in our territory. PAE is one of them. Glumax, another engineering firm that I know is doing some calculations around the potential of water heaters, large centralized water heaters as thermal energy storage devices. Ecotope's another company that's really helping bring this technology to market. So there's a lot of movement there, and to the extent we're talking about commercial buildings, getting more and more people to adopt centralized heat pump water heaters and to size the tanks on those water heaters based on maximizing grid interactivity is kind of the key transition for the space.
That's cool. Yeah, I noticed the Energy Star. A lot of the new manufacturing specs for hot water heaters on the even on the residential side are going to include these little communication modules that you're talking about, just standard. So it'll come with it automatic, and then suddenly it makes it a lot easier to imagine how this can happen without it feeling like it's a second project for the homeowner to have to.
Brian, that's a great segue. The very boringly named CTA 2045 communication spec, but one that's actually in code to be required for all water heaters built or sold in the state of Oregon starting January 1st of next year. And that's a huge shift. It means that all new construction and most of the retrofits in the market for the residential water heaters will already have this port there, and then just need a simple comms device plugged into that port to take full advantage of that thermal storage capacity.
So there, I know we're running out of time here. We're a little over the hour, and we've got so many questions in the chat. This one might be just an easy one. I think a builder is asking, is there any advice on proposing DM participation for our clients? Is it just a yes, do it, or and any thoughts on that?
Yes. I mean, I would say so. One of the reasons like Isaac and I like presenting on this is that it just hasn't, for whatever reason, just hasn't received the same attention. And so we just find that a lot of building owners, again, residential and commercial scales, just aren't even necessarily aware of it. And so just even bringing it to the table, and usually if you present it like, hey, a little bit of a change and you make money, most folks are like, that's intriguing, let's talk more. So
this is really where it really comes down to amplifying and magnifying the work of incredible engineering firms out there like PAE that do the calculation for you, that don't just stop at this is the standard I know, or this is the least cost entry point, that actually do a life cycle emissions and cost analysis on different systems choices. And so really big plug for firms like PAE that are out there doing this work on behalf of their customers to actually deliver much better products that not only are keeping us moving towards the path we need to be on in terms of clean energy, but are actually saving their owners money while delivering comfortable, high-tech, sustainable buildings.
Yeah, I know we're running out of time, but I wanted to ask one last question about vehicle to grid and vehicle to building, because you touched on it. You know, with the Ford F-150 is saying that it's going to come with that capability. All other EVs, as far as I know, aren't able to do that now. But you know, can you just maybe? I mean, it sounds like such an amazing proposition, because rather than buying, you know, a bunch of power walls or whatever, you've already got them in your parking lot sitting there. You got more actually than you would probably be able to afford to put in your home if you were putting in a backup battery system sitting there unused. Can you just briefly touch on what the roadblocks to that are, and how likely it might be that we see that in the next few years as a just standard thing?
Yeah, I think it's easier for me to start from the likelihood question and get to the roadblock question. From a likelihood standpoint, yes, I think that the potential that we're seeing on the imminent horizon, and it's not just at your home with your EV in the garage and the ability to power your battery, but think about schools and think about this transition that's already underway to move us to electric school buses and the size of the battery electric school bus. And then you think of, you know, the gym at your local school could be an incredible community resiliency center if it was able to tap into the batteries in all of those electric school buses in the parking lot. I mean, the potential is huge. And so the potential is going to drive the change. The technical roadblocks is really beyond my sphere of expertise, but my limited understanding is it has a lot to do with the technology and certification that's required for not just the battery, but the battery to the charger, to the smart inverter that's needed. And so to enable to reverse that flow of energy. So it's more around certification, testing, and enablement to happen.
Great. Joe, should we wrap it up here? I know we're over time. This has been great. We could keep going, but
yeah, thank you to everybody who put questions in the chat. We'll try to get to as many as we can every webinar, but really appreciate all your fantastic questions.
All right, well, thank you to our amazing panelists. We really appreciate your time and expertise, and thank you to all of you who tuned in. We hope this was enjoyable for you. If you have any questions you want to ping us, we'll try to answer them later. And if you're on the journey yourself towards electrifying your home, which we hope you are, We'd love to be of assistance if we can. Check out our website. There's lots of tips and even sometimes some ways to save money. And if you have questions about that, again, we're always willing to help. So if we can't answer it, we'll ask Karina or Isaac, and they will be able to help us. So thank you for tuning in today. Hope to see you at one of our future webinars, and good luck with all your electrification projects.
Yes, and huge thank you to Karina and Isaac for being on today. I put a link in for our webinar tomorrow on induction cooking in the chat. And so thanks to our panelists and thanks to all of you.
Bye-bye.
Everyone.
Thank you. Appreciate it.
Bye.